Greetings everyone. Okay, for today, talking about joint probability distribution. Now, whenever we talk about joint probability distribution, we're trying to look at the possibility of combining the independent variable and the independent variable together and to consider its product or its outcome. Okay, so we already know that a probability function can be discrete and it can be continuous. So let's just head on to solving joint probability function. So I said that a joint probability function considers two variables. Call it x and you can call it a y. And a function for y is given. So equation that entails joint probability can look like this, in that functions for x and y are given. Okay, so let's pick a little example and see how we can work on this. So here we have a function like 0, we have a function like 1 here, and we have a function like 2, and we have lastly 3 here. Okay, this is the colon heading for x. Okay, this is a colon heading for x. So x goes like this, while y cuts across this. So for y we have 0 here and we have 1 here. Okay, so the functions might be given here, the elements. So we have 0.1, we have 0.2, we have 0.1, and we can have 1 or 0 here, sorry, and here we can have 0.2, here we can have 0 and 0 here, and lastly we can have 0.4. Now these are the combinations. Okay, and by combination I mean the sum of this and this. Okay, meaning when this and this meet, the intersection of this and this gives us this. The intersection of x and y gives us this. The intersection of x and y here gives us this. When x is this, y gives us this. So furthermore, what are we supposed to do? What are the possible things we can do here? You might be asked to find the marginal probability. Okay, or you might be asked to find the marginal distribution. Okay, you might be asked to find the marginal distribution. So how do you find the marginal distribution? It's very simple. What are you supposed to do? You create a new column, okay, here from the equation, and don't forget that for x we have the formula. For x we have the formula that okay, let's say for x we have the formula that the function of gx is given as the summation of everything in I equals to 1 and everything in n, given that f is given as x here for I and y here for j. Okay, so this is a formula for that. So this is for y, for x, the function of x. So coming to this place, this is always g of x. Okay, it is not really stereotype depending on what you have here. Okay, so depending on what you have, you know where to place your function of g. So this is for, we are considering that x cuts across this place while y cuts across this place. So for the function of y, to get y gives us the function for y, we have the formula h of y equals to summation of m here. Okay, so j equals to 1 from the function of x j and y, sorry, I and y j. This gives us that for this is for y axis and this is for x axis. So how do you go about this? This simply means for g at this position, the values for x are 0 and 1. The value for this are 0, 1, 2, 3. So for g g of x, we have that the sum of this plus this plus this. So this plus this plus this gives us what? 0 0.4. 0, 0 0.1 plus 0 0.2 plus 0 0.1 plus 0 gives us 0 0.4. Are you good? Okay, so let's see the next one. This one becomes 0 0.1, sorry, 0 0.4 plus 0 plus 0 plus 0 0.2, giving us 0 0.6. Okay, so we've gotten our marginal probability of the x-axis. Don't forget, marginal has to do with range between in which a distribution focuses on. Okay, so between this one and this one, it does not exist this range. So the landmark, okay, or should I say the benchmark for this function of x does not exist this one. So for y, let's see the composition of y. I said this is for h of y. So h of y, this place gives me what? 0 0.5. Here gives me 0 0.2. Here gives me 0 0.1. That is, this plus this gives me this. This plus this gives me this. This plus this gives me this. This plus this gives me 0 0.2. So when you add this together, what should it give you? That is, everything here should give you what the sum of this gives you. Onto that, now what we are doing isn't wrong. So the joint probability function, when you add this and you add this, when you add this and this should be equivalent. So this plus this gives me 1.0, and this plus this plus this plus this also gives me this. So that means at this state now I am correct. So the final answer is this. And don't forget that the function for all the formula, the joint probability distribution states that the function known as a property now, that for p to be possible, p must lie between the range of 0 and 1. So this place must always be 1 for your answer, your table, to be correct. So with this now, I've been able to answer this question, marginal distribution. Whenever you're asked to find marginal distribution, what are you supposed to do? Just sum the entities here, this, and this, getting this, that's for the g function, g of x function, and this, everything here, okay? That's for the g. Now for the h, that's for the y-axis now. This is the x-axis, this is the y-axis now. So for the y-axis, we have that this and this should give you 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 this. And also, you now check it out. The function of this and the function of this should always be equals to 1. That's when you have the joint probability distribution. Anything outside this is not correct. Okay, so from this table, you might also be asked to find p of x. Okay, we have to find p of x. It's very simple, unlike what we've been doing ever since, that the probability function of anything is always equals to the sum of every this, right? The sum of this, where this equals to this and this is this, where this must always, the sum of this gives you this. So what does this mean? This means that equals to the function we have here for the x-axis now. Okay, for the x-axis gives us 0 0.4 plus 0 0.6, okay, which is equals to what? 1. Okay, and 1.0, anywhere you want to put, is still your choice. Okay, so with this now you are able to get this right. This is for p of x. Now if you're asked to find p of y gives you the same function for y, that the summation of this equals to this, the summation of this equals to this, okay, and n. So p here becomes y here instead of the x. Look at the difference. Here is x, here is y. Now I'm solving for probability function of y. That is a p mf of y, okay, which is equals to, that gives us, going back to the table, for y, look at the axis of y. So I'm going to add all this together. So this becomes now 0 0.5 plus 0 0.2 plus 0 0.1 plus 0 0.2, so which gives me 1.0. Okay, so we've gotten that as the final answer. Are you getting it? Look at what I did for probability function p of x. This is the formula which gave me this. These are the at the x-axis. This is the x-axis. You sum this together and it gives you this. Now for the y-axis, must be the same thing. You sum this together and it gives you this. Okay, so can we move? What is the next thing you might be asked to find? What if you are asked to find number 4? You might be asked to find f of x. Please note that it's still the same thing. Note that it's still the same thing. Note that it is still the same thing, which gives me that the integral of, that is the limit here, and the limit here, giving me the function of this x dx. Okay, so working with this now, we're still going to add everything together. We're still going to add them together at this state now. So this is, everything here must be equals to 1. This is a property. Everything here must be equals to 1. So when we're having this, it becomes this plus this, which gives me, go back to this plus this for x. So 0 0.4 plus 0 0.6, giving me 1.0. If you want to put just 0, if you don't want, you're free. Now for the function of y, we have to find f. If I ask to find f of y, number 5 now, if you ask to find f of y, that is given as integral of this and this minus this and this. So you have here that f of y, now you're using y here, right? Now the y, difference of y, is must be equals to 1. So when you're solving this now, this becomes equals to the functions you are given here: 0 0.5 plus 0 0.2 plus 0 0.1 plus 0 0.2. Everything should give equals to 1. You can put 2.0 if you want. If you don't want, you can leave it there. So this is everything about that. Look at this plus this plus this plus this equals to this. How did I get this? It's from this table, the angle of this. So this and this are almost the same thing. This and this are almost the same thing, depending on what you ask. The difference between this, the f that is continuous, this is for continuous now, this is for discrete. For the difference between this is PMF, this is PDF, this is PDF or continuous, this is PMF or discrete. The difference between this and this is just the function of this, and this. And look at the formula. This one is using summation, this one is using integral. Summation, integral. That's just the difference, right? So with this now, you should be able to know what to do from there to get your work done. Okay. Now let's see the next thing you might be asked to find. Okay, so this one now, number 6 says find the joint probability function of z, given that z equals to x plus y. So this is the table, the same table we had from the other flip. Let's see it, the same thing we had from the other flip. So I do not just want to be navigating from one page to another, so I have to take the pains of recopying it again. So it's the same thing, it's the same thing as what we had before. Okay, so we have this now. Okay, so from here we're going to use the cross tabulation method. The cross tabulation method. So we see that the first thing we have here is 0. So 0 plus 0 gives us 0, right? So the output of this and this gives us 0.1. We're done with that one. Now the next one says 0 plus this. 0 plus 1 is 1. So 0 plus 1. 0 plus 1 gives us the output of 0.2. Going to the next one, 0 plus 3, 0 plus 2 gives us 0 plus 2 gives us 0 0.1. 0 plus 3 gives us what? 0. Okay, so we are done with 0. Move to 1. So we have here 1 plus 0 gives us 1. But since we had 1 already, this is equals to 1, this is equals to 2, this is equals to 3, this is equals to 2. Sorry, 1. So if we put 1 here, you see that 1 will occur twice. So what are we supposed to do? We add it to this place. So that means 1 plus 0 gives us 1. Okay, so we call the function of 1 plus 0, that is, and plus 0 0.4. 0.4. Moving to the next one, 1 plus 1 gives us 2. 1 plus 1 gives us 2. 1 plus 1 gives us 2. So we have that 1 plus 1 giving us 2 is 0. So we can't rewrite the numbers twice. Just one number must appear in this outcome, right? Okay, so the next one is now 1 plus 2. 1 plus 2. 1 plus 2 is 3. So 1 plus 2 is 3. So that gives us the outcome. 1 plus 2 is 3. The outcome is 0. So that is plus here, please. We are adding them together now, just like what we are doing to this place. Okay, so the next one is now what? 1 plus 3. 1 plus 3. 1 plus 3. So 1 plus 3 gives us a 4. So 1 plus 3. 1 plus 3 gives us a 4. So that is the outcome. 1 plus 3 giving us a 4 is now what? 0.2, right? So 0.2 here. So with that you are done. So here we have equals to what? 0.1. This and this gives us equals to 0.6. This and this gives us what? 0.1. This and this gives us what? 0. And this gives us 0.2. So when you add everything here together, it should give you what? 1.0. Okay, that is the idea. That is the idea. So you've gotten that everything should always be equals to 1. You've gotten that right? So with this we are done. Sorry for the errors, please. Sorry for the errors. So this is a plus. This is a plus. I hope you understand the composition. The composition is what you should understand. The concept is what you should understand. Go through it again. Okay. So if you have to find the expectation of z, the z we just found here, right? It becomes the component of these functions multiplying the components of this output, that is of z, right? So this becomes, don't forget the formula for expectation. We have that expectation of this equals x of, if it is for continuous distribution, that's PDF, this, right? Don't forget this. So the function of x now multiply this function. So we have that this function is this one, while this other one is this component here. So that's what we're having here. This equals to 0 times 0 0.1. 0 against 0 0.1 plus 1 times 0 0.6. 1 times 0 0.6 plus 2 times 0 0.1. 2 times 0 0.1 plus 3 times 0. 3 times 0 plus 4 times 0 0.2. 4 times 0 0.2. Are you getting it? Which now becomes that this time this becomes what? 0. Plus 1 time it becomes what? 0 0.6. Plus this time it becomes what? 0 0.2. Plus this time it becomes what? 0. Plus this time it becomes what? 0 0.8. Are you getting it? So now this becomes equals to the total of this plus this plus this plus this. Becomes what? We have becomes 1.6 as the expectation of z, right? Look at it there. Okay, so we're done with that question. This you can go through it later. You can go through it to really understand it better. You can rewatch this video. You can rewatch it again and again. Please, you can go to my YouTube channel, like, subscribe, and share the video. You can comment your question on the comment box. Once I am free and I get to see it, I will answer the question as supposed. Okay, so thank you for your time for today. This is not the end, but we story for today.